Okay, now let's move on to the problem solving part. For number 31 to 32, given the vertices of quadrilateral ABCD, prove that it's a parallelogram. Okay, there are several ways to show that a quadrilateral is a parallelogram. One way is to show that the opposite sides are parallel using slopes. Another way is to show that the opposite sides are congruent using the distance formula. But how do we show that it's a parallelogram using the midpoint formula? So we can do that by showing that the diagonals bisect each other. That means their midpoints must be the same. So for a quadrilateral ABCD, by the way, we name a quadrilateral like this, ABCD. Okay? Consecutive points make up the vertices. So that means AC and BD are the diagonals. Okay? So AC and BD. And we just need to show that the midpoints of these diagonals are the same. So let's find the midpoint of AC. So A is 1, 1, and C is 6, 5. Now, what is the midpoint of these 2 points? That would be 1 plus 6 over 2, 1 plus 5 over 2, giving us 7 over 2. 1 plus 5 is 6. And if we divide that by 2, that's equal to 3. So the midpoint is 7 over 2, comma 3. Now, what about BD? Let's solve for BD. B has the coordinates 5, 2. And D has the coordinates 2, 4. Now, their midpoint, using the midpoint formula, that would be 5 plus 2 over 2, comma, 2 plus 4 over 2. This gives us 5 plus 2, that's 7 over 2. And then 2 plus 4, that's also 6, divided by 2, equal to 3. So as you can see, these diagonals have the same midpoint, 7 over 2, 3. And with that, we were able to show that this quadrilateral is a parallelogram. Next, number 33 to 34. Find the center radius form of the equation of a circle that has its center at the origin and passes through the point 6, 2. Okay, this one's pretty simple. So we know that the center is at 0, 0, and the circle passes through the point 6, 2. Since we already have the center, we just need to look for the radius. But how do we find the radius? Okay. The radius is simply the distance between the center to one of its points. And since we already know the center and we know a point on the circle, we can use the distance formula to find the radius. So using the distance formula, r is equal to the square root of, using the distance formula, that's 6 minus 0 squared plus 2 minus 0 squared. So r is equal to the square root of 6 squared plus 2 squared. So r is equal to 36 plus 4. 36 plus 4 is equal to 40. So the radius is square root of 40. No need to simplify that because what we're being asked here is the equation. And in the equation, we need to square the radius. So applying now the standard form, we have x squared plus y squared is equal to r squared. And the square of square root of 40 is simply 40. And this is our final answer. Okay? Sir, why is it not x minus h squared plus y minus k squared? Because h is 0 and k is also 0. So that simplifies the x squared plus y squared. Okay. Next, 35 to 36. Which trigonometric ratio can be multiplied to sine theta so that the product becomes 1? Justify your answer. Okay. We want to multiply an expression to sine of theta so that the product becomes 1. This property of numbers or expressions, no, is you have learned this in your grade 7, I think grade 7, grade 8 math. It's the concept of multiplicative inverse, or in simple terms, the reciprocal. Whenever we multiply an expression to its reciprocal, by definition, the product is always equal to 1. Okay? Or when we multiply an expression to its multiplicative inverse, the product is always 1. So the question is, what is the reciprocal of sine of theta? And the simple answer is 1 over sine of theta, right? And this makes sense because sine of theta, if we multiply that by 1 over sine of theta, this just becomes sine of theta over sine of theta, which is equal to 1. Okay? But, so, sir, are you saying that this is our answer? Well, technically, yes, it's 1 over sine of theta. But 1 over sine of theta can be simplified, no, to a trigonometric ratio, which is the reciprocal of sine of theta, which is cosecant of theta. And this is our simplified final answer. Okay? So it should be cosecant of theta because it's the reciprocal of sine of theta. Okay? So again, that's our final answer, cosecant of theta. That means sine of theta times its reciprocal ratio, cosecant of theta, always equal to 1. Okay? Because they are reciprocal ratios. And by definition, if you multiply a value or an expression to its reciprocal, the product will always be equal to 1.